All right, so it's 9:30 here in Norway. Welcome to this webcast, SANS at Microphone. My name is Chris Dale, and today I have for you basically an introduction presentation to Docker. So it's for us security professionals. So a little bit about myself. I've been a certified instructor now for a couple of years. I've been with SANS for many years, and I teach primarily the hacking techniques, incident response, and exploits class for SANS. That's SEC504. I'm just between jobs. I got some really exciting news just coming up next week, perhaps the week after. But I just resigned as head of cybersecurity at Netsecurity, and I'm going to build a new company, which is going to be exciting stuff, building something from the ground up. All right. So I am running this podcast or webcast pretty much alone. So that is, if you have any questions, right, let me know. I will address them at the end of the presentation. I do have one, never mind, my fault. Yeah, so just someone who said, hey, I can't hear the speaker. But to be honest, I can't focus on a go-to-training, go-to-meeting chat box while I'm presenting. It's really hard. So I'll just follow up with the questions at the end of the presentation. We'll see how long time we need. So first of all, why Docker? Well, Docker, it is a nice container technology allowing us to quickly set up small environments, fast, readily available, and it's reproducible. It always, well, what happens one time should happen the next time. It's all defined in code, and it's pretty much very useful for us. Instead of the more heavy virtual machines that they take longer to boot, they take longer to configure, etc., containers are in general faster. So very useful if you want to quickly spin up, for example, proof of concept. If you want to test the solution, we can normally run it up with a couple of commands, and a few seconds later, it is up and available for us. It is really, to be honest, really nice for our industry because it allows us to train on products and find bugs in products and set things up that was previously harder or more inaccessible than before. I'm not saying completely inaccessible, just that with Docker, we do have more people contributing to the community with well, repositories and Docker files to allow us to basically do these proof of concepts quick and easy, and it's quite nice. You can also, of course, use this not for only proof of concepts. You can use it for complete, fully production environments, and you can use, for example, Docker Swarm or Kubernetes to manage and administrate hundreds of containers if you would like. But that's not the talk that we're going to have today. We're going to talk about some things on how we can basically, in a very painless mode, set up services and get to practicing and start exploring this pretty nice technology. All right, so I'm just gonna quickly check one thing here. Yeah, the questions pane here is really hard for me to follow up. So I'm gonna follow up the questions at the end. It's pretty much impossible for me to scroll in a tiny little scroll bar here on an ultra wide monitor. So basically, instead of us focusing on setting up a service, for example, an Oracle database, where we have to consider a virtual machine with the necessary hardware and so on, we don't have to consider dependencies, and we don't have to necessarily consider all the configurations and so on. Instead of doing all of that, we can basically set things up with a simple command. So I wanted to show you quickly a demo where I just set up, for example, an Oracle database. Because the Oracle database, for me, has for a long time been something that I needed to do proof of concepts on, because I was doing SQL injection attempts against an Oracle, and I would love to have that Oracle database behind the scenes supporting me while I'm writing my queries, so I know that will work or not. So basically what I've done is that I've basically done a Docker login here. So I've done a Docker login, presenting my Docker credentials. They are stored insecurely on my system right now, but basically it allows me to authenticate to Docker Hub, where different repositories and images are available. Now, Oracle has an image for the Oracle database, and they do require you to authenticate and accept some terms of services before basically downloading this image. So basically, I've already downloaded the image. I can go say Docker container ls. You can see that I have an Oracle database enterprise version 12.201 currently running. And I can interact with this database by basically saying Docker, I can say exec, I can give it a parameter. Now these are actually two parameters, -it, so it's -i for interactive and -t to assign a sudo tty to this executable that I'm going to run inside of the executable, or sorry, inside of the container called Oracle DB. So I'll specify the container like this, and I'll say bash. I've already executed the Oracle database here because it takes a few minutes to set up. I don't want you guys to wait for me to having to wait for services to get up and running and so on. So that's why I've already run this database. But basically, I will show you on the next slide the command to make it run. It's just a simple one-liner. It's neat, clean. It's not a big deal. So now you can see that my prompt just changed. I just executed bash inside of the container named Oracle DB, and I told exec here to give me an interactive terminal, basically. So the prompt has changed. From here, I want to go basically following the tutorial from Oracle. They have given me some instructions that I need to source, for example, bash rc here. This is because bash rc contains the password, for example, the SID, it contains Oracle Home, and it contains interesting variables that are useful for me to basically use while connecting to this database. Now I want to go ahead and do my proof of concept. And luckily enough, in Oracle Home, we actually have an executable called SQL Plus that we can use for connecting to the database. So here we should have SQL Plus. You start it up, enter a username. Actually, let's do no log here, and we'll do connect. And I'll have to provide it with an SID, so a schema, username, and a password. Now these are just going to be the default credentials here, so I'm just going to go ahead and do sys, which is my username, then provide the password, which is going to be a default or a doc, and then db1, and then I'm going to connect to the database, which is called OIRCL CDB, and I'm going to authenticate as sysadmin, sysdba actually. So now it says connected, and from here I can basically go explore. I can now, for example, try to do a select 1, 2, 3, 4 from Jewel, for example, and I can see that I get results. Maybe I want to experiment on how to make a union query, figure out, or how I can maybe pull out the version number from the database that I'm targeting in real life. So maybe I can learn that there's actually a view called v version, and I can select data from this view version here, and I can see that there's an Oracle database, 12c Enterprise Edition release, so and so, and I can basically start playing around with this and explore and get some hands-on knowledge. This is pretty useful in my opinion. Now there are other ways of doing this as well. You can set up a VM and you can do it in different ways, but with Docker, all that I just did was I ran these few commands here. They're not very complex. First of all, this command is just from the Docker Hub, a web page that I will show you soon. I basically copy this little string on the right side here from Docker Hub, and then I wait for Docker to download all the necessary images and so on. This database was about 2.4 gigs, which is in fact the largest image that I have on my system right now. Then I tell basically Docker to run this image. I tell it to detach so that I don't, so I'm given my prompt back and the Docker is running in the background, so I detach it. I also, in this case, told it to run interactively with TTY. I give my new container because I'm now going to run the image, and I'm going to have a name for this container now called Oracle DB. All right, so I can give it whatever name that I want it to have, but each container must have a unique name. Then I basically point it to the name of the image, and if I have different version numbers, which you can perfectly have, you can, for example, replace this version number with the latest. I will now boot up a container running this version of the image, and it's quite easy. Then what I did, I just ran this Docker exec, running it inside of the image, and in this case, in fact, when I just did the demo, I did it in a more manual way to show you the steps building up. But in this case, I'm actually telling exec here, telling exec to run a command inside of the container named Oracle DB, and I'm telling it to run bash. And then I give bash arguments. I tell it to run the following command line here, to source bash rc, and then to run SQL Plus with a no log parameter. and then basically connect to the database. So pretty useful, pretty easy, and it's quick to get up and doing proof of concepts. Better yet, these proof of concepts that we're doing are defined in what we call as infrastructure as code. They're all defined in configuration files, which make this 10 times more beautiful. Because with configuration files, it means that when we try to replicate this, when I give you a Docker file or tell you to go pull an image, the same things should happen on your system as on my system, giving us much more predictability of what should happen. It allows us to basically configure and describe the environment using a configuration file, and it's pretty beautiful. Nice thing with containers as well is that it's isolated on our own host. So whatever we now install, for example, the Oracle database, this database I can now easily remove from my system. I can go say Docker container here, and I can say ls, and I can say stop Oracle DB. Now it's turning off gracefully all the services, and then I can type Docker container rm Oracle DB, and this database is wiped away from my system. Easy mode. Instead of me having to uninstall and have all kinds of artifacts and register keys and install scripts left and right with dirty things in it, I don't want that. I can just remove things. Now I can say, for example, Docker image, and I can prune, and I can remove any images that are not in use. And I don't want to do that right now. So I can basically remove those 2.4 gigs that was used to set up this database. So kind of nice, I would say. Instead of cluttering your main OS and like turning things dirty, you can do very easily proof of concepts, install tons of artifacts without making a mess. And like the alternative to this would be me creating a bunch of snapshots for my VM, right? And I would snapshot before and after changes and so on, and it's a bit more hassle to deal with. And also VMs are much slower. In fact, Docker and containers are not virtualization. They are not using a hypervisor like, for example, VirtualBox, Hyper-V, or VMware are using. No, 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 no. Dockers are actually utilizing different techniques to make the containers fast, efficient, and clean on your system. And they're using features of the Linux kernel, actually. That means if you're running Docker off of, for example, Mac OS X or from Windows, you are probably, or you are running a Linux VM from behind the scenes. For example, if you want to run Docker off Windows, silently behind the background, you're going to install Hyper-V. Hyper-V is going to pull down a Linux image, and from that Linux image, you're going to be doing the virtualization. So that's kind of a neat type of thing to think about. And it uses different features to allow us to do this containerization. For example, it uses a feature of the kernel called namespaces, allowing you to create small, like separated, isolated groups for things like mount points, processes, network connections, IPC, inter-process communications, and users. For networking, it uses virtual Ethernet interfaces and bridges and IP tables to allow things to communicate. And for storage, it uses normally these copy-on-write file systems that allow you to be very small and not take a lot of storage space unless you actually reclaim the storage space or claim the storage space. And it has some different file systems that it's using. For example, Btrfs and this Union file system. I can't remember the correct name for it. Another Union file system, I believe it's for. So it uses these basically Linux kernel features and some additions like, for example, these file systems. Pretty nice. Now, we could go explore this. What we could do, for example, is that we could, for example, boot up a little, say, Docker Ubuntu image. So we could go pull Ubuntu and we could give it a version, for example, 18.04. This will basically reach out to the internet and try to pull out an image for Ubuntu version 18.04. Now, I luckily had this image already downloaded, so you wouldn't have to see me download all of these megabytes from the internet. But basically, I can see that I have this image by typing Docker image ls, give the -a to view everything, not just the running images. And you can see that I should have an Ubuntu here with version 18.04. Now what I can do now, I can say Docker run this image. I can tell it to detach, give it a TTY, and give it a name, for example, Ubuntu 18, and then give it the image itself, for example, Ubuntu, and then the version number that I want. Now this just created a container. I can verify that this container is running by typing Docker container ls or ps. For example, ps and ls, they're the same commands here. I can see that Ubuntu for this image here is up and running, and the name is Ubuntu 18. Just like before, I can go investigate. I can go Docker exec. I can say exec with IT. I can say the image Ubuntu 18, so that's a container, run bash. And just like that, my prompt changes. From here, I can run PSAUX, for example, see which processes I can see. And notice that I don't see a lot of processes. In fact, if I were to open up another terminal and run PSAUX in here, I see everything that is on my system. But in the background here, in the container image, I can only see processes that have been created from within this container. In fact, from within this namespace. I'll show you what I mean in a second. For example, what I can do is I can type, for example, inside of this container, I can type, for example, top. All right, top will show me how much memory, CPU I'm using, and so on. And you can see the top here is running with a PID of 21, and the user root is running it. Let's explore. I will now, on my host system, outside of the container, grep for top. You can see that I can see that the process top is running somewhere. This is actually from within the container. Top is running, but the PID is actually 23796. So there's actually that's not the same PID as what I'm seeing from inside the container. So from outside the container, I can go check. I can go check the proc file space and check the folder called 23796. And in here, there's an NS folder. And here you can actually see the namespaces in use for this given process. We have a control group up here, and this is the control group identifier. You have the IPC, you have the mount, you have the net, and you have the PID namespace. And what you could do now is that you could quickly create a script that will find any other process. So from outside the container, you can create a script to find any other process that is attached to this PID namespace, isolating things away from one another. You can also see this with PS3. You can give it a command like this, ps3-p, and I can go find this top executable and see where it's running from. You can actually see it here. So from systemd, we have containerd running, which is some of the technology from beneath Docker. So Docker is using containerd, and containerd is using runc again. And from inside of here, you can see bash here. You can see top is created here. So that's how that is basically working. And we can see these lines pretty clear now. What about, for example, network communications? Can we see network communications? Netcat, do we have network here? I don't have netcat, so I'm going to skip that demo. I don't have app, do I? Apt? Yeah, we do have app, so I can do apt updates. Sure, let's install netcat real quickly, although I might have some problems describing, finding all of the things I need to find. But let's do apt install netcat. Oh, netcat. Right, so my question is, from within the container, can I do netcat listen verbosely port 1508 and listen on a port? And can my host operating system see this port? For example, netstat NAP. This will give me a list of all sockets and TCP, UDP connections, and so on. And I will grep for number 1508, my favorite number. And I don't see it. I don't see anything listening. Is it actually listening? I'm pretty sure it is. We could go to another another container window here and basically interact with it. So we could, for example, here type in bash, and we can do netcat localhost 1588. And you can see that this socket is actually up and running. Perhaps we could check with Google, for example, ncatgoogle.com on port 80. So that seemed to work. Yep, that works. So we can set up a connection to Google. From outside the VM, can we see this connection? let's grep for 80 and pipe to less. And from outside, even if we have an external connection going outbound through my network card to the internet, I still can't see with Netstat the connection that my container is making. I cannot see any Google traffic here. So how would we go about this? Maybe we would, maybe SS knows about it. If we can do SS grep 80 and look if we see any established connections to Google's IP address, but in fact we don't here. What about LS of PY? Maybe we can grep for 80 here and see if we can find that connection, but we don't see the connection. So this container and using the namespaces is actually hiding the network connection for us quite well. What we could actually do is that we could use tspeeddump. Now tspeeddump will give us answers. So first of all, let's do host google.com here. Sure, let's do tspeeddump, do not resolve names, 260, 58, 207, 206. And host, sorry. Let's try now this connection one more time. And you can see that I do actually have this synac act happening, and I can see it with tspeeddump. There's also an interface called Docker 0, which I can tell tspeeddump to sniff on, and that will show me the packets from the container itself. But what if you wanted to sniff packets from the container and manipulate packets and reroute packets and maybe use an intercepting proxy to do hacking, for example? There are ways of doing this. And for example, we can use Docker network to start investigating the network functionality of Docker. For example, Docker network LS will show us some information about the networks that I have. You can see that I have a bridge interface, a host interface here, and none. Basically, these things here can be used to accomplish networking. In IP tables, you can also see that I have several rules pertaining to the Docker interface and how Docker should work. So there are IP table rules here that will facilitate access from this VM. But I can actually do things from my hosts affecting the container. For example, if I want to intercept traffic, I can use IP tables to reroute traffic. For example, I can use natting. I can tell it to pre-route, following my cheat sheet here because these things are not fresh in my mind. Tell it to do TCP protocol, and I can do destination port 80, for example, which is often something of interest. We can redirect this into, for example, to port 8080, for example. So what would happen now with this rule is that IP tables will collect that connection to port 80 that we make from netcat here, and it will reroute it to port 8080, where I can have, for example, an intercepting proxy running. For example, I can have, say, man in the middle proxy running. So I will do this with 443 as well, and then I will run man in the middle proxy with the mitten dump command to basically have a command line overview of what's happening with my proxy. Now we can go back to our container and try go to Google with netcat. You will see that, hey, we have a client connect, Control-C, you have a client disconnect, and that allows us to basically, well, intercept these things. So pretty useful stuff, very useful in terms of hacking because we can run all kinds of containers, all kinds of applications, and we can intercept their communications and start to fuss them and investigate to see if we can find something interesting. So what I'm going to do now before we continue, I'm just going to quickly delete these two rules up here that I just created, just in case I don't want it to mess up any demos following later. All right, so pretty cool. Docker, something else than virtualization. There's also Docker Compose, which works with Docker, except Docker Compose will set up multiple containers in an orchestration. Like it will orchestrate multiple containers together, allow them to network together, for example, and set up things based on dependencies. So maybe you have a database that needs to run first, and then you want to run, for example, an application afterwards. The SQL has been running, and it's very useful. And most of the time, when you want to run multiple containers that have been set up using a YAML file with Docker Compose, all you got to do is run Docker Compose up, and a few seconds later, you might have 5, 6, 7 containers up and running on your system, and it's just that easy. It's really beautiful. So basically, if you want to see which images that you have, use this command as I've shown you. You can also build images from Docker files. So you can go off GitHub, for example, download someone's Docker file that describes an image and describes the base image that this image will be using and so on. You can build it, give it a tag, and basically now you have an image that you can start a container from. And to start a container is just simply Docker run, give it a name, and then give the name of the image that you want to boot up, give it a version, and it's easy. Here's one of those example Docker files. Here you can see that I'm pulling off an image that is called, well, a base image that is called node current slim. So we have this image which will give us some functionality. Then we're setting up a work directory. All of these parameters you're seeing in the Docker file can be used by the command line, by the way. So this work directory is basically the current directory the process will land into inside of the container. This is exactly the same as giving the parameter -w in the command line. We then want to copy a file over. We want to copy this file over to dot inside of the container. Then we want to run inside of the container npm install. Then we want to expose a port to the host operating system. So from within the container, we want to expose port 8080, and we want to run a command that has an argument start, npm start, and then copy the remaining files. It is really easy, and I want to show you how this works. So what I'll do is, very fast, I'll just look into a file. Let's see, I think it's in Slingshot here. Yeah, node. Here, I have this Docker file, okay? So it's just a file that we just saw, expose, npm install, and so on. I have a package JSON that contains some, for example, dependencies for npm, for example, so for node. So for example, I want to have the express web server, I want to have group for building and so on. I want to have all these dependencies, all of that stuff I can put inside of here. And then I have my application, my node application, which is just console log hello world, okay? Now, if I want to build this, I do Docker build, give it a tag, for example, node, and then point it to the current directory where the Docker file is, okay? So give it Docker build, and all of a sudden, if I type Docker image ls, you will see that I have a node here that was just built. I can now say Docker run, and I can tell it to remove any previous containers that I've run with this node to give me a clean start. Give it the -it to make it interactive again. Doesn't necessarily need this, to be honest. And then give it a name, for example, node testing, and then I can say node. And that will allow me to build this and run this image now that I just built. So you can see that it says hello world. But what if I change this code now? If I do vim app.js, change this code to say hello exclamation mark. If I run the application again, notice that it just says hello world still. So if I were now to change this and make it basically get the changes, I would have to rebuild this image. I would build dot again, give it the same tag, for example, or a new tag, and then I can now run Docker node 2, for example, and it should say hello world with all exclamation marks. So that's basically a quick and dirty example of how these things work. By the way, we're inside of the VM, inside of the container here, sorry. Old habits die hard, huh? So here I'm inside of the container that was the Ubuntu 18. Have you ever thought about the file system, where the files are stored, etc.? Well, let's take a look. For example, here I am inside of the roots home folder, right? So inside of the container. Now let's go into the roots home folder inside of the host. Those are different directories within the file system, but they look to be the same ones, but they're not, right? So this is from my host here, it's from my host, and this is from a container. So I want to find where this file system is. Where can I find the files that my containers are using? For example, let's create a file, echo test into, for example, this unique name here. So now inside of my container, in the root directory, I have a file called xcountlyku. Cool, let's look for this file. Find / name xcountlyku.txt and redirect errors into dev null. Now we will see the file systems that have been created by Docker. And you will see that you have inside of this overlay 2 folder a file called xCampliQ here. So I can copy this, cat it out, and you see that it says test. What I could also do, I could now overwrite it potentially. For example, echo hello world into this file. And from here, cat xCampliQ, you can see that it has now changed to hello world. So there are ways to reach into one another's spheres and namespaces here, but this is not a namespace. Now you're just reaching into someone else's file system. And that's what we're doing here. So it's pretty cool. It is pretty intriguing. And it's basically something that is very useful for you security professionals to be using in your work. Also, Docker has great help files. The online pages are beautiful. And also the command line itself is quite useful as well. So from the command line, any command has a -- help command, right? So from here, I run docker -- help. I can, for example, now do docker image -- help, and I can see all the subcommands for image. And that allows me to explore, and it's quite intuitive to allow me to basically figure out how these tools work and start playing around with it. Because not every time you have an answer on Stack Overflow, sometimes you actually have to go figure things out yourself. So from the basics, you can just pull out an image from Docker Hub, and Docker Hub is this beautiful web page that contains tons of images. I'll show you guys this website soon, but basically just point it to a name from the web page, and you will go online, pull out a Docker file, and then start collecting all the dependencies from this file. Here's some useful commands for you to know about as well. For example, Docker run takes in some optional options here. You have to run an image, and then you can give the image commands that it will run after the fact that the container has started. So you give it a command and arguments, and that's it. Docker PS or Docker LS to list containers, like same thing here as this one. You can also stop containers, you can start containers, you can remove them, and very useful as well, as you are now going to be playing around with Docker more after this presentation, I hope. You might sometimes want to prune something, right? And this basically allows you to remove all the junk that you've made. Any stop containers or images that are not in use anymore, you can wipe them off and start with a clean slate, so you can start experimenting more without having the feeling that you're messing up your OS, right? So at Docker Hub, we have this beautiful list of categories on the left side. I want to open this website because we do have why not do a live presentation, right, instead of just PowerPoint slides? So at Docker Hub here, what I like to do is I like to go up and explore up here. So you see the explore button. And from here, I'm not always sure what I'm looking for because I wanna do some, say, hunting for vulnerabilities or learn something new. So I'll go over here on the left side and say, for example, DevOps tools. And just out of the gate here, we have SonarQube, which is a brilliant free open source tool that will allow you to do code checking. So you can do static code analysis to check it for bugs, code smells, and also security vulnerabilities. And you can set it up to scan continuously. You can scan your developers repositories and so on a continuous basis. And it doesn't require you to do significant investments in project planning and sit down in meetings left and right. No, you go run one command. You go run this one command here, and then you open up SonarQube and you configure a little key and you give it a repository and you're done. You will get a report coming out of that. This is easy. This is done in literally 15 minutes. Or maybe I will go explore, say, application services, where I have WordPress or Elasticsearch or MQTT here to basically go exploring. Lots of cool ways for us to get knowledge and get some hands-on experience with things. Maybe you're looking to apply to a job and they're saying, hey man, you should have some experience with Redmine, but unfortunately you don't. But then you arrive at the job interview and you tell them, well, I have run Redmine a couple of times. I've set it up, I played around with the admin interface, but I don't have any certifications, or I haven't looked into the details of it. But by just having that little bit of hands-on, it might just give you the edge, and the job might go to you instead of someone else. So for me, this is tremendously powerful. This is really, really cool. And we've had this for VMs before, but it's just been a much more tedious and slow process. So into hacking, we can also use these containers to help us hack. And there are multiple ways of doing this. For example, I can go pull out the image that is called the damn vulnerable web application. And I found this damn vulnerable web application. I found it off Docker Hub, okay? And the web application is basically, the container is basically, well, the image is called vulnerables, web DVWA. And I'm telling it to run here. I'm telling it to remove any previous data it has, telling it to be interactive, giving it a port option here. So I'm telling it to expose internally port 80 to my host port 80. So that if I connect to my own port 80 host, I will connect it to the internal host of the Docker container on port 80. So I run this command here. You can see here, it starts up an SQL server, a MariaDB that is, it starts up Apache, shows us some logs, and it's ready. From here, I can go to, for example, Internet, Firefox web browser, take us to localhost here on port 80, log in with admin, password, and just like that, we have the VWA up and running. Create reset database, and please log in. Let's do this. Admin, password, and here we are ready to practice, ready to experience hands-on hacking. We want to hack some file upload. Maybe we want to do some SQL injection, see if there's a vulnerability here. Put in a tick, and it says, you have an error in your SQL syntax. Ooh, actually, I have a great idea. As I said, I just resigned as head of cybersecurity at Netsecurity, and they gave me some gifts, okay? First of all, they gave me the gift, the Script Kiddies Cookbook by Matthew J. Bassam. This is from 2005 or something like that, and it's really funny. It talks about Ethereal, and it talks about, it's Script Kiddie book. It's really funny. And they also gave me the certificate, Certified Script Kiddie to Chris Dale, to Commendable Skiddy Activity while at Netsecurity. Yeah, I love my colleagues. They're a cool bunch. I will be very sad leaving them. However, it's what it is, right? This business, I want to start something new. But they also gave me this T-shirt. This T-shirt says, I was head of security at Netsecurity, and all I got was this T-shirt. It has a QR code here. Careful, don't scan this. I think it got an attack in it. Also has an attack on the shoulder here, or on the arm, and that's basically, it's basically a shell shock. You see that? Shell shock. Now, on the back, I had an idea, because the back actually contains an SQL injection. And it looks kind of messed up, this injection, don't it? It says test tick or tick 6 blah tick divided by 2 minus 3 equals hello tick and then hash. Now this is designed to bypass web application firewalls and filters. And they're trying to do this. They're trying to do this. Tick or tick 1 equals tick 1 tick hash. This is what they're trying to do, listing out all of the users of the database, creating a tautology. But why don't we try what I got on my T-shirt? Why don't we try to do, so we'll do test, or then we'll do 6 blah, and see if this will evaluate to true. Divided by 2 minus 3 equals, and we'll do, instead of 1 here, hello. And it works. That's a web application bypass vector. So that's pretty cool. All right, so we can go practicing. We can go start doing all kinds of cool things here, XSS testing and so on with the damn vulnerable web application. But of course, there is more. There are many, many containers out there, especially within the repository called vulnerables. But there's also Metasploitable, for example. And I wanted to show you Metasploitable too, because Metasploitable is different than the damn vulnerable web application. Metasploitable will basically allow you to practice network penetration testing. And let me do some copy pasting here to save us some time. I've already pulled the image. So if you see my images here, you see Metasploitable 2 is downloaded, 1.5 gigs. And I can run this image now from my command line. Notice that it's running Metasploitable, but it's running a command starting up a script that is built into the images. It's called services.sh. This will basically start up all the vulnerable services inside of the image, and then will give us a shell here with bash. Okay, So let's run this, and then from a new window, let's do MSF console. Then from a new window, let's do nmap 172.17.02. Depends on what IP address we got here. So right now we have Metasploitable up and running. I type ifconfig from within the container. So notice that I'm inside of the container right now. I see my IP address is 172.17.03. Let's see if this host is up. And look at all of this here. Just within 15 seconds or so, I got all of these services, most of them vulnerable, exposed to me for practice. And I can go learn how to do network penetration testing. I can try and gain experience. In fact, we can try something right now. I can use an exploit that I know is working for one of these services. So use exploit, Unix, IRC, set our host, paste in IP address, exploit, and we will actually take over this IRC here. This IRC server is vulnerable. Command session 1 opened. So I'm using MSF console Metasploit from a host to hack into the container. I can type sessions into rack 1, and just like this, I'm on the container itself. And I can run commands. Pretty cool, in my opinion. We can also use Docker for research. And I can, for example, with Docker, I can go hunt for applications that I want to find bugs in. For me, working in the penetration testing and offensive services field, I want to find bugs in the applications that my clients are using. For example, I might have a client that is using the CMS, the publishing system called Ghost. So what I want to do is I want to run Ghost and see if I can create some useful dictionaries and start some scans from a white box perspective before targeting the customer or while I'm targeting the customer, so that I can better learn how my attacks are going to work and what's actually going to work at all here. So for example, what I can do is that I can set up Ghost. So let's quit out this here. Let's do Docker container ls. Okay, so it's no longer running. Then we run Ghost. Notice what I'm doing here. I am setting up an internal port 2368, and I'm mapping it to port 8080 on my host system. So this is from within the container, and this is from within my host. Then it's creating all kinds of SQL tables and so on, and in a few seconds, it's done, right? Then it says that the site is available at localhost, and this is actually not correct, because what I'm seeing right now is from the container itself, okay? So the container is reporting me logs from Ghost, but I know better. I'm from the host looking into the container right now. I need to either access the container's IP address or the port that I just mapped. So what I can do is I can open up internet here, and I can go to localhost, and then we basically say port 8080. And here we have Ghost up and running. So now if I wanted to, I can, for example, say from this window here, sure, exit out of Metasploit. I can, for example, do wapiti URL, hit this now, start to scan and see if I can find any vulnerabilities from my own box on this Ghost CMS, right? Give it a verbosity here. Should be a root URL. Let's see. It's not wapiti. What is missing? http:// actually looks good. What am I missing? Let's try copy paste it from a cheat sheet. I did prepare in advance here, just in case of demo gods. You never know, right? So here you can see wapiti is now scanning this application, looking for vulnerabilities, trying to find something, right? And while this one is looking for vulnerabilities, maybe we have our own scripts to look for fancy stuff. I can also set up Ghost now. I can go say Ghost here, and I can go basically go through the installation process to make myself familiar with how this product works. For example, test at test.test, and then we have to provide a semi-good password and do this later. And now I can see from the admin's perspective what my customer will be seeing. So I can now create word lists of all of this functionality. I can even go explore the file system and basically create myself a very targeted word list that will allow me to fully explore the target file system and web application that my customers have. And we can do this actually. Why don't we do Let's do Docker container ls. So I want to show you that we have it running here, and it's called strange chown. So let's do Docker exec it. Let's do strange chown bash. And now I'm inside of Ghost. So here we have the files, and I want to check. Does my client expose the config production JSON file? Does it contain anything sensitive? And if it's containing something sensitive, well, I want to notify my customers. I will basically do a find dot and take all of these files, perhaps not the node modules, but anything other than these. I will check to see if my customer is basically by mistake exposing something they shouldn't, for example. Hopefully you see the value in this as well as I do. There's also other things that I've been doing. So maybe some of you have been following my YouTube channel, and you've seen that I've been doing a lot of work from within my VMs themselves and basically polluting them quite a bit. For example, in one of the videos, I very easily set up a little PHP server by basically installing PHP on my host and running with a dash capital S here. So I set up a little web server. This can also be very easily done from a container. So from a container, I can just say docker pull PHP, and then I can basically run a container with this image PHP and tell it to set up a PHP web server on this IP address 000, which means all interfaces, and basically expose this port number that I wanted to expose. Let's try this. Let's just try it. Why not? Seeing is believing. So let's exit out of this. Let's do docker container ls. Let's stop this image called strange chown. That's just the default name that it was assigned. And let's now basically run up this image of PHP proof of concept. We'll give it up. This is actually very important that I explain. We will attach to it a volume. Okay. Now this is you mapping files from your host operating system into the containers file system and operating system. So I want to map some files, for example, files from the current working directory, okay? Then I will map them into a folder on the target operating system, for example, /temp. Then I will give the container, a starting work directory. So from where should PHP start executing, or where should I run the PHP commands from? Well, that's going to be from temp as well. And then I give it the commands, right? Then I say, which image first of all, so PHP latest, and then I give it the commands, just like the syntax tells us to do. We'll tell it to do, for example, PHP capital S, and I don't want to know the IP address of the Docker container here, so I'll just give it 000, give it an IP address like 15.08, and also I'll need to expose the port number. Actually, I don't need to. Actually, I do need to do this, I believe. This should, I believe it should work. So let's do --rm. That should work. All right, so now you see that we started up a PHP server hosting anything in the current directory. Now, I don't have anything in the current directory except node files. So why don't we go into this directory where we have a test.php, run the same command. See how fast these containers are? It just takes me literally seconds to go from one container to another and play up new examples and new stuff here. I'll open up my browser, go to localhost on my favorite number, and here we have PHP, but we'll go to test.php, and there we have the PHP info, the test.php file that we're currently seeing. So we can go back to the background here, we can cat test, and it just runs PHP info. I could also run this file directly from a command line. I don't have to open up my browser, and that's basically what I show you on the slide here, run in a single script. So that's how you would run a single script here, instead of setting up a web server. Okay, pretty cool. Where can you get started? Well, I'm using the Slingshot distribution from SANS, which is a Linux distribution that we're focusing on to basically allow students to have a consistent experience across virtual machines that they take with them from class and allow them to have an environment to practice and train on. A consistent and reliable environment that is tested and where you spend less time trying out how to build tools and rather run tools and understand techniques of what's going on. So do check out the Slingshot, and once this pandemic is over, we're going to invest more in Slingshot as well. We're going to bring up the gears and basically take it into fast track. So that's my final slide. Before I go to the questions, I will thank you everybody for listening. I do have some social media out there. If you would like to follow me, that's up to you. If you connect with me on LinkedIn, though, please let me know where you found me from. So let me know that you found me from this webinar, or maybe you're coming in from YouTube, where maybe you don't have the web camera, you can see me, you can see the t-shirt that I present and so on, but let me know that you saw it on YouTube. And that's useful for me to know who to accept and not, right? Because sometimes it's a bit problematic. I am starting up a company as of next week, so if you're looking for someone to do your offensive work, let me know. But that's just my shameless plug there. Now let's go into the questions. So let's see, how does this interface work? Oh, okay, wow, it's really bad. So let's see. Okay, I could expand the columns now. Let's see questions. First one, I'm just going to read it aloud and then process it together with you guys. What is the relationship between, for example, Jenkins that allows continuous testing and on the go with Docker? If it's so that, for example, Jenkins cannot work without Docker? No, Jenkins is like a continuous integration, continuous delivery platform that will build source code for you. It will have build processes and so on, can run completely independent from Docker. And maybe Docker can be used alongside with Jenkins to give Jenkins more capabilities, but Docker and Jenkins completely separate tools that don't need any relationships to one another, really. I've been using Jenkins a lot and never in conjunction with Docker, to be honest. Let's see. And at the same time, what is the relationship to continuous red teaming? Docker is a product, right? So Docker is basically a collection of clever ways of using the Linux kernel and using different software to allow you to create these small containers to do something. Docker is a product, yes. The version that we're using now is free and it's easy. But they do have an enterprise version. They also have a competitor to Kubernetes, for example, and so on. So in relationship to continuous red teaming, I would say that there's not necessarily a big relationship. It's just that red team, for example, as I showed you in this presentation, we can use containers to quickly get up and running with, for example, a bunch of different command and control frameworks, and we can test code and put them into production fast. All right, let's see. Why use Docker instead of VMs with checkpoints and or VM copies? Right, I believe I did explain that. Certain things do not work in VM guests. Like, for example, using GPU to increase faster crack performance. Does Docker overcome such limitations? Yes, you would see that Docker has more access. So Docker will not go through a hypervisor to access resources. Instead, it will go through the kernel requirement, or what I would say, you can configure a container to limit its memory and so on, but it will have pass-through capabilities, different pieces of hardware. So I would assume that, for example, GPU could be accessible through a container image. I have not tried it myself, though. But that's a cool question. I recommend you go check it out. So the question is this Linux only, or can you run Windows hosts in Docker as well? So I did answer that during my presentation. This is Linux only when you install Docker on Windows. What's happening is behind the scenes, you're installing a hypervisor, for example, Hyper-V or VirtualBox, and from there, you're silently going to the internet, pulling out an entire Linux VM where Docker will be running from. So when running Docker pull, how do you verify that you're pulling down secure, safe Docker container images that aren't malicious or haven't been blocked or backdoored? That's a great point. So these Dockers are not, like, they can be breached, right? They're isolated, but there could be vulnerabilities. Like there was a vulnerability in Run C allowing escape from Dockers and so on. But you will see that there are some images on the Docker hub that have been vetted and verified. You have official images and verified publishers up here, and they will have a natural more trust. But the same question would of course apply to how do you trust anything of GitHub, for example, right? How do you not know if something is backdoored? It's hard, isn't it, my friend? How is this free? They're offering some premium service. Yes, they do have Docker Enterprise and Docker Swarm and so on. Have you used Docker on Windows? I do not use Docker on Windows, Harpal, because I'm using VMware Workstation and Hyper-V, which is a requirement for Docker on Windows, and VMware Workstation. They don't play along, so I have to select one or the other. The demo is excellent. Thank you. I've learned a lot about what Docker. Awesome, cool. Thank you very much, Alfredo. So let's see, what about Docker and the segregation of environments, such as application and database layer in DMZ, etc.? Let me think of it. What about Docker and the segregation of environments, such as application? So yes, you can, for example, why don't I show you a Docker compose file? See if I have something here. For example, dispatch from Netflix, which is like a SOAR platform or incident response platform, not sure what to call it. Here, I will have a folder called Docker, and we have this Docker compose file. So this Docker compose file will allow us to set up different containers. For example, a DMZ, an application server, in this case, an SQL server, and yeah, looks like it's just an SQL server and PG admin here. But basically, from here, you can see that you can add dependencies, you can expose ports, you can also put them on different networks. So you can add networks within Docker. So if you do not Docker network --help, here you can see that you can inspect networks. For example, I can inspect Twitch, for example, or whatever. And also I can also create networks to use the namespace nets and also IP tables to allow segmentation here. I will not guarantee any of the security whatsoever here. Okay, I'm just a messenger. Will the slides be available, Scott? Yes, I will put the slides out on Twitter. Okay, and also on LinkedIn. Don't worry about it. It will be. I might have another glass of red wine. So if it's another glass of red wine, I'll put it out tonight. Wow, fascinating your presentation. Cool, thank you. So let's see what the question is here. As you would recommend that we begin to know all of this new world, apart from SANS links, some basic Docker container book or PDF. Yeah, where to get started? I'm very practical myself, so I like to just go about it, saying I have a destination and the road to that destination is not predetermined. So I go out and I start just trying, and I run the commands. I go to the documentation, I RTFM, right? I read the fine manual, and I just study. Maybe I find some answers, maybe some tutorials, but unfortunately, Alfredo, I don't have something, or Julia, sorry, I don't have something for you right now that I would recommend outside of the Docker help files that you have from the Docker command line, as I showed you, or the web pages. Let's see, we're closing up in 3 minutes here, guys. Let's see. We found SonarQube is very limited vulnerability scanning. Yeah, the developers love it. Yep. Commercial tools like beep, beep, beep made it to SAST. Tools like beep, beep, and beep provide better results. I agree, Stuart. I will not endorse any vendors. Sorry. Yeah. But yeah, it is what it is, isn't it? But what I want businesses, so you're obviously, Stuart, what I want to take away from this. So Stuart is recommending some more commercial vendors for static analysis of source code and so on. Like I showed you SonarQube. The thing is, there's so many companies today that don't do nothing. They don't do anything. They're like sitting in a tank, a black box tank with no visibility whatsoever. And they're like looking at what's the next big box we're gonna buy. But if you have any hackers in that organization, if you have someone who's willing and who's capable, you can go start experiment and get some experience before you select the vendor, and maybe see if this is actually something for you or not. All right, so let's go through here. Is memory analysis or any other digital forensic technique possible for containers? Yes. If so, how much harder is it? So it's not very much harder, Andrew, because from within, so let's see if we have any containers running right now. Yeah, so I do have one container, right? Ubuntu 18. And this container will have different processes, right? So if I do ps3-p again, it will have different processes. For example, oh, Firefox here. For example, I believe this up here is going to be from this Ubuntu. Now I can go explore here and go copy off the memory of these processes from the folder here. So I can go look into the memory and environment as I would want to from here. So in terms of memory analysis, you have a lot of capabilities and it won't stop you very much. Like if you have root on the host operating system here, it's pretty much game over. Is Docker just for testing? Can you use Docker for production system? Yes. If so, how do you secure these environments? Right, so that's a great question. So Docker is used for production actually, and it's also used alongside with the orchestration platforms like Kubernetes or Docker Swarm and so on. And basically, in order to secure them, you want to probably integrate with some dependency management tools to make sure that Docker containers are not pulling in vulnerable or later to be known vulnerable dependencies. Maybe have some reporting and scanning of them and so on. That's basically what they're doing right now. If you look into, for example, DevOps tools and oh, actually, I think there's a poster that we have from SANS, DevOps SANS poster. Yes, this one here. So you will see that on this poster here, the DevOps poster. So secure DevOps toolchain. This is what you Google, right? You will have some things that will help you to keep, for example, Docker containers secure. And I think one of them was called immutable infrastructure Docker here, but I saw one that was called Docker Scan, or here, yeah, Docker Secrets for secret management, for example. And you also had another one that I forgot the name of right now. I did look into this quite a while ago, and look into basically a static scanner for containers. And that's what you want to look into. Okay, so let's see, one more question maybe. Yep, let's do. Slides will be available on my Twitter or LinkedIn or by SANS later. Also on the SANS webpage, actually. They will put it on the webcast webpage. Is there a possibility to find malicious process escaping the Docker sandbox? Yeah, definitely. If you go look for baseline and find anomalies and like baseline your systems to see what's up, you will probably be able to discover that potentially. Okay, so that's the final question, and I've been able to cover all the questions then. I appreciate all your nice comments, everybody, trying to sift through them. Everybody, thank you very much for saying nice things. Here's the last question. Can you explain the relationship between Docker and Kubernetes, as Docker seems to have lost mindshare among many developers? Okay, so Docker is one container, and Kubernetes is allowing you to basically cluster this container or many containers across a ton of different services, for example, and maintain these containers in a elastic scaling, for example, and do main operations on them, for example, and make sure that they're up and reliable and so on. And Kubernetes is just like the winning side of then the opposite side is called Docker Swarm. That's Docker's answer to Kubernetes, sort of. But the Google, Amazon, and Azure and so on, they basically have taken Kubernetes into the worm, and most people have started using Kubernetes instead of Docker Swarm. All right, everybody, it's been a pleasure talking to you. So stay safe out there, and everybody's health to all your health, and I see you next time, okay? I do have a class coming up, actually, 15th of June. I have a 3-week class on hacking techniques, and it's pretty fun. Keep my web camera on all the time, and it's very engaging and interactive. Cool. Cheers. See you, everybody. Bye-bye.